Calculate the magnitude of the average gravitational force between Earth and the Moon. Show all your work, including the equations and the substitutions. Okay, so for finding the gravitational force, we have to use universal gravitation. So we can't just use F equals mg because we're talking about planets. So the gravitational acceleration is not a constant 9.81. It depends on the mass of the planets and how far away they are and all that other stuff. So in this case, force of gravity is g, the universal gravitation constant, times the mass of the first object times the mass of the second object, all divided by the distance between the two objects squared. So we have to look up all these values if we're going to have a fair chance of doing this right. So if you look on your reference table, you will have mass of the Earth equals 5.98 times 10 to the 24th kilograms, and the mass of the Moon is 7.35 times 10 to the 22nd kilograms, and the average distance between the Moon and the Earth is 3.84 times 10 to the 8th meters, and the universal gravitation constant g is 6.67 times 10 to the negative 11th, and it has units of, and you'll never remember this, I wouldn't recommend that you try, newtons times meters squared over kilograms squared. And these are just the units that g needs to be so that it cancels out with the masses and the meters in the bottom to ultimately give you newtons for Fg. Okay? So when we plug all those in, I'm not even going to bother writing them all again. Just plug in g for g, plug in mass 1 and mass 2 are the mass of the Earth and the mass of the Moon, and r squared. And if let's just go ahead and put that into the calculator. Okay, so g is 6.67 times 10 to the negative 11th, and that's being multiplied times the mass of the first object, which is the Earth. We'll say 5.98 times 10 to the 24th, and that's again times the mass of the second object, which is the Moon, 7.35 times 10 to the 22nd, and then that's being divided by the average distance between the Moon and the Earth, 3.84 times 10 to the 8th, and that's being squared. And we get the force equals 1.99 times 10 to the 20th. And now let's just check the units, even though we know they should theoretically work out. We have Newton meter squared over kilogram squared, although I didn't write that here. It should be kilogram squared. And that's being multiplied times two masses, so that's kilograms squared, and then being divided by two distances, so meters squared. So the kilograms cancel, the meters cancel, and we're just left with newtons. So that should do it. 1.99 times 10 to the 20th newtons is the average gravitational force between the Earth and the Moon.